Good afternoon, everyone. I do hope everyone's enjoying the conference so far, and I have seen the desserts outside, so I'll try not to keep you too long. And today I want to talk about my favorite subject, and if you can't tell by the pink, that's Gleam. So unfortunately, I'm actually not CTO at Rover anymore, but I am head of engineering at a company called Medfin, as a very recent switch, which is a financial operating system for UK dentistry, interestingly enough. But as painful as it is to admit, I am also a YouTuber. And that is where our story is going to start today. So this is going to be a bit of a self-indulgent portion of the talk, so I ask you to bear with just a little bit. But I think it's important to have context, because I didn't come into Gleam deliberately. I didn't sit down and research, what's the perfect language for me to learn in 2025? Like I mentioned, I'm a YouTuber, so I originally started making videos about Python. I was a data engineer at the time, and that's the language I was using at work. And I got a bit fed up with the kind of slow beginner tutorials you see on the internet a lot. So I started a series that I called Impatient Devs, and I tried to teach a language to existing developers as quickly as possible. And on here you can see I've got Python, Go, Zig, but I did a few more as well. But suddenly I started seeing a lot of YouTube coverage for this language I'd never really heard about before. There was a lot of hype around the release of this language, Gleam, which was created by some little British dude. And it seemed like it was taking the internet by storm. And being a YouTuber and a good little clout chaser, I jumped on the bandwagon. And I made another video. So I did the first one, I did another, and it turns out that when I'd made that Impatient Devs video for Gleam, I'd fallen in love with the language and the community around it especially. And suddenly I'd inadvertently become the Gleam YouTuber, or there is an official term courtesy of Louis, which is the Glambassador. And as you can see, I decided to stick with Gleam, and today I'd like to talk a little bit more about why, and the things that ultimately convinced me to make it my entire personality. I even have Gleam socks on today. And why I put it in production at Rover, which is my previous company. So firstly, Gleam is very, very simple. And people can sometimes be scared off by static type systems. But Gleam's philosophy is very much there is one way to do something. And that makes it really easy to pick up the language in literally an afternoon. And I'm really serious about this. It's the only language that I learned for the Impatient Dev series that I remembered how to write after publishing the video. And it's got a very familiar syntax for folks coming from C-like languages, which are my background personally, and also the most popular languages these days. The compiler is smart enough to infer types almost all of the time. So if they scare you, you can just kind of let it do its thing and pretend they don't exist, but still have the safety sort of enforced by that. The language also only has 22 reserved keywords, and only 15 of them are actually currently in use. The other 7 are reserved for potential future features, so there's not actually a huge amount that you need to try and get your head around. But this isn't just good for you learning Gleam. It makes Gleam adoption really easy, and we've seen that with Yoshi's talk earlier this morning, both for your own sort of personal project or at your company. And your whole team could be productive using Gleam within a week. Even that team member, you know who I'm talking about. But don't be fooled. Just because Gleam is quite new and quite simple, it doesn't mean it can't be really powerful and expressive. So let me give you a bit of an example. Of the keywords I mentioned earlier, my favorite is this one in the bottom, the use keyword. And that's because it's very, useful. With it, you can implement all sorts of features that you'd normally need special keywords for in other languages. So you can use it to replace Go's defer, or Python's context managers, so you can omit telemetry or run cleanup code when you're done with a resource. You can emulate early returns in a language that doesn't have them, keeping control flow really simple, but without going really deep down that tree of nesting. And you can even nicely chain middleware, so it's really easy to see the path your request is going to take. So what does this keyword do? It can do all of these things. It must be really complex, right? Well, no, actually. So all it does is flatten out a callback. That's it. So you get all of these great features, you're just writing functions without that pyramid of doom from the nesting I mentioned earlier, from the callback-based code. And it's simple, like well-designed things like this that make Gleam code quite elegant without loads of hidden control flow or days of having to read documentation to pick it up. So how do you get started? Well, as you might know by now if you've been in this room all morning, Gleam doesn't have its own runtime. It usually is compiled to Erlang to run on the Beam, but it can also compile to JavaScript. And this, plus the ability to use FFI, or foreign function interfaces, to call out to these languages, makes it incredibly easy to adopt Gleam into your codebase incrementally. This @external annotation on a function declaration lets you choose a language you want to target, so Erlang or JavaScript, and then you just reference the module and function you want to call. That's it. All you have to do is make sure that the types are correct. As smart as the Gleam compiler is, it can't type check across a boundary to languages that don't have static types. But because of the JavaScript interop, people can actually come into and get a lot of use out of Gleam without needing to learn anything about the Beam. Because while the Beam is very powerful, and we should definitely be encouraging people to learn it, that's why we're all here, it's also quite different to other virtual machines and can be quite daunting at first glance if you're new to something like that. And according to the most recent Gleam developer survey, most people don't actually come into Gleam from Beam languages. It's usually web backgrounds like TypeScript and other C-likes like Python, Go, Rust. And I couldn't fit every other language used by Gleamlins, which is the official term, on this slide. So have a look at this one. The number of people who come to Gleam from Beam languages only represents about 7% of the total Gleam population, but the numbers from the survey show that about 2/3 of Gleam applications actually run on the Beam. Or to put it another way, rather than replacing languages like Elixir, Erlang, or LFE, Gleam is growing the Beam community as a whole, and I personally think that's fabulous. It's the first time I've ever used the Beam. It was my introduction to it, and I realized that the Beam is this incredible piece of technology, and it really deserves to be more widely celebrated. But what if you're not trying to introduce Gleam into existing projects? What if you do want to write something from scratch? Gleam is pretty new. It's been in V1 since about April, March time last year. So does it have everything you need to get the job done? Well, actually, yes. Like I mentioned, Gleam programs can take full advantage of two incredibly mature and combat-hardened runtimes. And Gleam really does take full advantage. For the backend folks, which I imagine is most people here, there is a robust, type-safe implementation of a lot of OTP that lets us tap into the Beam's famous concurrency model and fault tolerance. And many of the ecosystem libraries are built to use this from day one, like Wisp, which is a framework for high-traffic web servers. We've got Lifeguard and Bath, which are Poolboy and Nimblepool-inspired pooling libraries, respectively. We've got Barnacle, which is a Gleam implementation of Elixir's lib cluster for creating those clusters that just don't die, and M25 for queued background jobs. And any Brits in the room will understand the reference here. And of course, we have clients and query generators for pretty much all the major databases, including the ones I was too lazy to find the logos for. In particular, the Redis and Valkey client for Gleam uses Bath, that pooling library, under the hood for connection pooling. So it's just one less thing for you to have to think about. And for the more front-end aligned, Haley already mentioned Lustre this morning, but I'm going to plug it again. It's a web framework that takes the Elm architecture of the model view update loop and allows you to run it on your front end in JavaScript, but it also bridges that gap to the back end, providing server-side rendering and kind of live view-esque server components that allow you to do some real-time things from the Beam. If you missed Haley's talk earlier, I can recommend this one from Lambda Days 2024, where Haley talks about how Lustre components can run anywhere. And because it's all in Gleam, it's all this one language, you get all the benefits that the JavaScript and TypeScript folks tout of being able to share code from the client to the server without having to run JavaScript on your server. So I want to take a minute to talk about why I put Gleam in production at my previous company. how was it deploying Gleam and relying on it to satisfy our customers? I was CTO at a small startup called Rover, and we turned code into function graphs and then looked for bad patterns to make sure that bugs sort of didn't happen as much as we could. Originally, we were mostly a TypeScript shop, and despite being sort of this Gleam ambassador, even I underestimated how easily we could fit Gleam into our tech stack. Because all of these things that I've been talking about today, they made the process super easy. As did, of course, all the things I haven't mentioned, like Gleam's incredible build tooling. We started using Gleam to orchestrate all of the background jobs that happened in our system. The type system and exhaustive checks on pattern matching, along with your usual Beam goodness like supervision trees, gave us total confidence that our code would handle just about anything we threw at it. And that bit of Gleam code has been chugging along without a single incident since we deployed it all the way up to today. And we were able to lean on the Gleam ecosystem for what we needed, but we knew that we could dip into Erlang or Elixir packages if we wanted to. And then, of course, there was the impact on the team. Like I said, it was a small startup, there were only a few of us, but the others all picked up the language in literally a matter of hours, and now they're all Beam converts too. In fact, they loved Gleam so much that they were pushing quite hard to rewrite our internal admin dashboard to use Lustre and server components so that we could see everything going through our system in real time. We even added Gleam support to the product, so we could create graphs of all the function calls in a Gleam codebase. For those curious, this is what the standard library looks like. But because of the simplicity of Gleam, I was able to do this in 2 days, rather than the multiple weeks and many, many bugs that were involved in doing this for other languages. It's a function graph, and who knew how many ways you could call a function in JavaScript? But, I'm just a dude who spends a probably unreasonable amount of time in front of a camera, so why do you have to listen to me? Well, I'd appreciate it greatly, to be honest. But if you don't want to take my word as gospel, I've gathered a few case studies from other folks I know who actually also run Gleam in production. People like Mark Holmes of Williams & Holmes, and they use Gleam to make sure that distributors can get their food and drinks from their warehouses to their suppliers and ultimately into your meals and hopefully the delicious desserts outside. And Mark said this: "What's so great about Gleam isn't how fast and simple it is to build things, although that is true, but it's how easy it is to come back later and refactor. Maintaining Gleam applications is a really great experience. I want you to put your hand up if maintaining old code is the most fun part of your job." Nobody, basically. Well, with Gleam, it actually could be. Or you could listen to the creator of Nestful. And this is a local-first productivity app that uses CRDTs to resolve the state of to-do lists, even if you've made loads of offline changes across multiple devices. And they said that Gleam's type safety and ergonomics do so much heavy lifting that they make a solo developer look like a small army. And Nestful is actually really cool and written almost entirely in Lustre. And there's loads of great detail on their technical blog, which I've linked here for those curious. There's also Steerlab, which is an AI platform for winning software contracts. Their product, again, almost entirely Gleam microservices around RabbitMQ, and their VP of engineering, Guillaume, has contributed a lot to the Gleam ecosystem, especially, again, around the Lustre ecosystem. And they told me that Gleam is the best choice they made for their team. They've got type safety across the stack, and it's drastically cut down the number of bugs that they experience. And last, but certainly not least, is Peter Saxton, who is one of Gleam's oldest production users. He was the one who actually wrote the original JavaScript backend for Gleam, and he's currently trying to redefine how we think about software reliability with his own programming language, EYG. And of course, EYG, written in Gleam, the website and the editor, all in Lustre. And Peter had this to say about his experience using Gleam for EYG and Indie, the current company at which he works. "Since we really understood the benefits of Gleam, we haven't written a single test. Fearless refactoring is real." Now, I'm not going to say you should never write another test, and I think they actually have started writing a couple, but they go a lot longer before they find it necessary. So, hopefully by now I've given you a bit of convincing and you want to go away and use Gleam at your place of work. So, how exactly do you go about it? Well, the first thing to do is to get comfortable with Gleam. And like I said, it won't take long. My teammates did it in a few hours. But you can use the Gleam tool to get a feel for the language, its syntax, and how it operates. It all runs in the browser. It uses a WASM build of the compiler and compiles to Gleam's JavaScript target. So it all runs pretty quickly. And if you want to go a bit deeper, there's also the Gleam Playground, which is an extension of the editor in the tool that exposes the JavaScript and Erlang code that your Gleam will compile to, if you want to understand a bit more about what's happening under the hood. And this is one of my favorite personal contributions to Gleam, and I find it really useful if I'm doing that kind of FFI, foreign function stuff, to figure out what shape my data is going to be when I'm writing those foreign functions. And like I said, that's kind of the next step. You start adopting Gleam incrementally. You use FFI to call out to external Erlang or JavaScript or Elixir code from Gleam. Or you can import your built Gleam modules into any of those languages, as demonstrated earlier by Yoshi. And from conversations I've had with the Gleamlins who've successfully infiltrated their workplace, Gleam's type system is really, really helpful when you have part of your system that always needs to handle every possible case. A lot of people, especially in sort of Haskell and those languages, talk about functional core imperative shell. When you're working with a cross-language codebase with Gleam, Gleam is very, very good at that functional core because everything is typed and you know you're handling every possible case. Because the compiler will scream at you, literally scream at you, if you miss anything. It's also very good for the boundary between your front end and your back end because you can reuse your types, and that just makes life much easier. And slowly, over time, you'll do what I did. You'll become very Gleam-pilled, you'll start wearing Gleam socks, you'll become utterly unbearable to your coworkers and anyone you meet at any meetups, until they become Gleamlins too. Thank you.
Thank you for the talk. We have about 2 minutes for questions. Do we have any questions from the audience? Okay, not from the audience, but I have 2 questions from the online folks. So the first one was, any performance issues? How does it compare to Erlang or Elixir? So I suppose it's a question about the Gleam as a whole.
Yeah, well, Gleam just compiles to Erlang source. In a lot of cases, it looks very similar to Erlang you might write yourself, so it'll have similar performance characteristics.
Okay, and we have a second one. Does Gleam allow multiple function clauses like in Elixir?
No, you just write multiple functions, generally. You can't have different arity functions with the same name.